Hey everyone, welcome back to this Python series. My name is Ansh Pathania and today we are going to start our most important topic of Python, which is object-oriented programming. So without wasting any time, let's get started. Before we write a single line of code, let's answer a fundamental question. What is a programming paradigm? A paradigm is simply a style or a way of thinking when writing code. As software evolved over the decades, programming style went through three main stages. The first stage is procedural programming, which also means sequential lines. Second style is functional programming, which is also called reusable logic blocks. So let's understand this by a code. A is equals to 10, B is equals to 20, and sum val is equals to A plus B. Print sum is sum val. This is our first style. Procedural programming. Our second style is functional programming. Which is also called as reusable logic blocks. In simple terms, it means function. Creating a function is a reusable logic block. Function is a reusable logic block. We can reuse it by calling it return A plus B. Calculate sum 10, 20. So as you can see, this is the procedural programming and this is called functional programming. Now let's move to the next thing. Now imagine you are developing a video game like PUBG or Free Fire. If you used procedural programming, you'd need separate variables for every player. Player 1 health. Player 1's health is equals to 100. Player 1 weapon is equals to AKM. And player 1 position is 50. Player 2 health is 100. Player 2 weapon is M416. Player 2 position is 120. Now imagine 100 players in a battle royale match. You would have 300 loose variables. How OOPS solve this? OOPS say stop creating loose variables. Combine the player's data, which means attribute, and actions, which means method, into a single entity called player object. Attribute means state. For example, health, weapon, position, skin color. These all are attributes. And methods called behavior, which means shoot, move, heal, reload. These all are methods. Now there are 4 pillars of OOPS. In object-oriented programming, everything revolves around these 4 core pillars. First is encapsulation. Second is abstraction. Let me check in the PPT if I have written those terms. let me just tell you the definition. So first one is encapsulation, second is abstraction, third is inheritance, and fourth is polymorphism. Now encapsulation means wrapping attribute and methods inside a single class unit, like protective capsule. Abstraction means hiding complex internal details and showing only the clean interface to the user, which is required, which is important. Inheritance means creating new class based on existing class without rewriting the code. In simple terms, we inherit our some facial features from our parents. Inheritance is like inheriting qualities from a parent class to the child class. Now moving on to the next, polymorphism. Polymorphism means performing a single action in different ways depending on the object. In today's video, we master class, object, constructors, encapsulation, and abstraction. So now let's move to section 2, classes, object, and memory layout. Now let's define the two foundational terms, class and object. A class is a user-defined data type that acts as a blueprint or template. It occupies no real space in memory for instance data when defined. Now object means an actual physical instance created by the class blueprint that occupies RAM space. Let's understand this by an example. First, we are defining the class blueprint. Class student. We are defining the class student and putting the value current. Our second step is to use of object, which means physical instance in RAM. S1 is equals to S student print S1 dot name. Now again, S2 is equals to student print S2 dot name. Let's run the code. Now here class student uses the class keyword to create a custom data type named student. Name is equals to current creates a class attribute inside the blueprint, and S1 is equals to student calls the class name like a function. This tells Python to allocate memory in RAM for object S1, and print S1 dot name uses the dot operator to access the name property inside S1, which outputs current. And S2 is equals to students create a second independent object S2 in RAM from the same blueprint. Now think of a class as an architectural blueprint drawn on paper. Can you sleep inside a blueprint paper? No. It's just a set of instructions. An object is the physical house built on a plot of land. Using that blueprint, you can build 100 physical houses from one paper blueprint. Now let's prove that S1 and S2 are distinct physical houses in RAM memory using Python's ID and dict feature. So let's remove this first. Now inspecting the memory address, print memory address of S1. ID S1. Print memory address of S2. ID S2. Now we've inspected the memory address. Now we are inspecting the internal instant dictionary. So S1 attributes S1 dot dict S2 attribute. Let's run the code here. Now ID S1 versus ID S2. It returns two completely different RAM numbers, as you can see. 138, it is a random number, right? 138451345382464, and our second memory address for S2 is 318451345382512. The last three digits are different. Now this proves S1 and S2 lives at different physical memory locations. Now moving on to the S1.dict. Every Python object contains a hidden dictionary dict that stores its personal instant attributes. Currently both returns empty curly braces because we haven't assigned unique instant data yet. Now let's understand the concept of constructors in it and self. Right now both S1 and S2 have a hard-coded name, Karan, but every student has a unique name and unique marks. How do we pass custom data when an object is being initialized? We use the constructor method in it. In Python, any method with double underscore on both sides like init is called magic method or dunder method. Let's understand this by a code. We have defined the class here. We have to define a init function. We have to add the double underscore here. Init self comma name comma marks. Self dot name is equals to name. Self dot marks is equals to marks. And let's print. We are going to use f string here. Creating student object for self dot name. let's remove here. Now this is the parameterized constructor. And this is instantating object with argument Rahul, 85, and which print s1 dot name comma s1 dot marks. S2 is equals to student Anita, big capital Anita comma 94, print s2 dot name comma s2 dot marks. Let's run the code. Now as you can see, in the output, creating a student object for Rahul 85, and creating student object for Anita 84. Now here let's break down the code. Def init self comma name comma marks. Here this line number 4, it means the constructor method. It runs automatically every time student is invoked. Now what is self? Self is an automatic reference variable pointing directly to the current instant calling the method. And here self.name is equals to name, takes the argument name, for example Rahul, and binds it to s1 dot name. S1 self dot marks is equals to marks, binds 85 to s1 dot marks. Now when you run s1 is equals to student Rahul comma 85, Python secretly translates it to student dot init s1 comma Rahul comma 85. Notice how s1 is automatically passed as the first argument into self. Now what happens if you forget self in the constructor or call it with the wrong number of arguments? Let's understand this by a code. Let's define another class, bad student. Def init marks, name is equals to name. Now here self is missing. Let's run the code. Now wait a minute guys, first s is equals to bad student Rahul, 85. Rahul, 85. Let's run. Now, as you can see, the type error is in the terminal. Now let's understand why did this crash. Because Python automatically sends S as argument 1, Rahul as argument 2, and 85 as argument 3. Since init only defined 2 parameters, name and marks, Python gets 3 arguments and crashes. Always include self as parameter 1. Now move on to our section 4, which is class attribute versus instance attribute. Now, data in an object-oriented program belongs to one of 2 levels. First one is instant attribute. It means unique to each individual object stored in the objects, means self.dict. And second, class attribute means shared across every single object created from the class, stored in the classes student.dict to save memory. Let's understand this with an example. First, we'll define a class student, college name is equals to A B C D Institute of Technology. This is a class attribute which is shared with all students. Class attribute. Shared by all students. Def init self comma name comma marks. Now this is our instance attribute, unique per student. Self.name is equals to name, self.marks is equals to marks. S1 is equals to student Rahul, 85. Is to Anita, 92. Print s1 dot name, comma, college, comma, s1 dot college name. S2, comma, name college S2. Let's run the code. Now let's break down the code first. First we've defined the class student, college name. This is a class attribute which is shared by all students. All students have same college name. All students are from same college. College name is ABCD Institute of Technology. Now, once college name is declared directly inside the class body, Python stores this string once in memory rather than duplicating it 1,000 times or 10,000 times for 10,000 students or 1,000 students. Here self.name and self.marks declared inside init. Each object maintains its own private copy. So everything inside the init is the instance attribute. Each object maintains its own private copy. So this is the code. This is the difference between class attribute and instance attribute. Let's move on to the next. Now first pause this video and predict the output of this code. I'll write the code and then you have to predict the output. Just wait a minute. First I'll write the code. ABCD Institute of Technology, same S1. Let's remove this. To remove this. Student dot college name is equals to XYZ University. Print S1 dot college name. S1 dot college name is equals to PQR Institute. Print S1 dot college name and S2 dot college name. Now you have to predict the output of this code. There are two cases. This is case 1 and this is case 1 and this is case 2. This is by class name and this is by instance name. Tell me what this line print and what this line print. Now let's run the code first. As you can see, the case 1 output XYZ University, changing student dot college name, updates the shared value for all instances that haven't overwritten it. Case B output S1 dot college name becomes PQR Institute, but S2 college name remains XYZ University. Why? Assigning S1 college name is equals to PQR creates a new instance attribute on S1 that shadows the class attribute S2, still looks up to the class attribute. Now moving on to our next section, methods, abstraction and encapsulation. Now let's talk about the adding behavior to our class using methods. We will look at two types of methods today. Instance method, which requires self to read modify instance data, and second method is static method. Utility function that do not touch self or class data. Let's understand this by a code. So let's remove the college name. Let's remove all of this. Okay. So instance method. Def get grade self if self dot marks is greater than equals to 90, return elif self dot marks is greater than equals to 80, return A, else return B. Now static method. Utility. @ static @static method. Def is passing marks return marks is greater than equals to 33. S1 is equals to student Priya, 88. Print. We're going to use f string here. S1 dot name comma s grade comma s1 dot get grade. Now calling here at last we are going to call static method. Print is 28. Pass in comma student dot is passing marks 28. Let's run the code. There is a name error, student where 19th line, student capital S. Again attribute error 20 line, get grade. Get s1 dot get grade grade grade. There's something wrong in the code. I have to get tab. Oh my bad guys, there is an indentation error. Now it will work. Again is passing marks. Now it will run. So now let me explain the code here. First we have defined a class student. We have used constructor def init self comma name comma marks, and self dot name is equals to name, self dot marks is equals to marks, Now, def get underscore grade self is an instance method. It uses self dot marks to calculate and return a. Here, static method is a decorator informing Python that is passing marks is plain utility function logically grouped inside student, and def is passing marks here this one. Notice there is no self parameter. It can be called directly as student is passing marks 28. So this is the code. Now let's solidify two major OOPS pillars that beginners tutorials often confuse: encapsulation and abstraction. First, let's talk about encapsulation, which also means data binding. First, let's define. Definition of encapsulation is wrapping data or attribute and methods into a single protective unit. The real world analog is a medical capsule. Inside one single capsule cell, multiple chemical ingredients are packed together. Now, moving on to abstraction, which also means hiding complexity. The definition of abstraction is hiding the background implementation details and exposing only essential controls to the user, which is needed, which is important. Real world analog is driving a car. To stop a car, you press the brake pedal. You don't need to understand hydraulic press, brake pads, or friction physics happening under the hood, which means hidden complexity. You don't have to know the physics behind the braking system or braking pads, the friction, nothing. You just have to press the brake pedal. Now let's combine everything we have learned: classes, objects, init, instance, attributes, instance, methods, abstraction and encapsulation into a complete real world bank account management system. So this is a real world project. So let's build a project here. So we have to make a bank account management system. So for a bank account management system, what we need? Account number, a balance, amount, and credit, debit, and balance, all of this. So let's make this. Class. First we have to define the class account. Def init self comma account number comma balance self dot account number is equals to account number self dot balance is equals to balance debit is withdraw method def debit self comma amount if amount is greater than self balance, print, we have to use f string here, print transaction failed. Insufficient. Funds in account. Else print else self dot balance, else self dot balance minus is equals to amount, print f amount debited from account. Self dot account number. Print f updated balance. Self dot get balance. Now we have, this is the debit. Now we have to make for credit. Credit deposit method. Deposit method def credit self comma amount. If amount is less than equals to 0, print invalid deposit amount, else self dot balance plus is equals to amount, print if amount credited to account, self dot account. print if updated balance self dot get balance. This is the credit. Now we have to make for the balance helper method. We can add the insufficient balance account. We can add the account number here. Self dot account number dot now for balance get balance helper method def get balance self return self dot balance. Print welcome to Python. Account account 1001 comma balance is equals to 10,000. We have created the account here. Now we have to perform operations. Account 1 dot debit 2500 print into d5 account 1 dot credit 4000 print 35 account 1 dot debit 15,000. Now let's run the code. So the transaction failed, insufficient fund in account 11001. Now let's break down the code first. We have created a class account. Here def init constructor it has account number, balance, and self account number, balance, and after that we have made a debit method which we need amount. If amount is greater than balance, the transaction will fail, and else if there is sufficient balance, the amount will be debited from the account and the balance minus amount, and it will print the balance and account number. And we've created a second method. Our second method is to show the credit method is we need amount. If amount is less than 0, and we'll print invalid deposit amount, and if it is greater than 0, we'll add the amount in the balance and print the amount credited to the account number. And after that we have created another method which is balance helper method. It will help us to get our balance after all the debits and credits. And this is all the logic, the operations we have performed in this is we have made account. So now suppose initially we have 10,000 initial balance, debited 2,500, and remaining will be 7,500. Credit amount is 4,000. The remaining, it will add 4,000 into the balance. It will be 11,500, and we'll debit 15,000. It will block because 15,000 is greater than 11,500. So that's all for today's video. You have officially taken your first major step into object-oriented software engineering. So thank you for watching. That wraps up our chapter number 6. This wraps up our chapter number 8. Oops, our first part. So now you have officially taken your first major step into object-oriented software engineering. That's it for today's lecture. Thank you.